This is a homework help video on the binomial distribution for Chapter 5 Homework for Statistics. For this discussion on the binomial distribution, I put the first part of the lecture at the beginning of this homework video so that I can go over it just in case you happen not to have understood it or perhaps you didn't read it. What we're talking about here is a binomial distribution, and it is a special kind of probability. In some ways it sort of looks like the probability that we just did for the discrete probabilities, but it's a little different. In this case you have a variable, but it only has two possibilities. Either it's a win or a lose, or it's a head or a tail. There's only two outcomes. Remember the other one we did, how many girls are in a family? Well, there were four outcomes, 0, 1, 2, 3. 0, 1, 2, and 3. Okay, so there were four outcomes for the number of girls in that three-person family, in that three-child family. Here we're going to have a distribution which the variable can only have two outcomes. For example, if you have a sports game, you either win it or you lose it. That's it. Or that's how we're going to look at it anyway. We usually call those successes or failures. Of course, it depends on how you write the problem. What is a success and what is a failure? There's a probability for success, and that's called P. And the probability for failure is Q. Obviously, since all the possibilities have to be add up to 1, P plus Q has to equal 1. So if you know P, it's easy enough to find Q, or vice versa. And here's the example. So you have a chance of winning with 75%. Then P would be 0.75, or you could use fractions, 3/4. Sometimes that's easier to use. Then Q is just 1 minus P, so there's a 1/4 or 25% chance that you're going to lose. If you're tossing a coin and it's a fair coin, the chance for heads, if you're looking for heads, would be 1/2. The chance that it comes up tails is also 1/2. Usually those probabilities are determined by experience, or they're given to you. You usually don't have to find the probability that you'll win or lose. That's determined by the game that you're playing. But the purpose of the binomial distribution, or the binomial probability formula, is to answer a question like this. Say you want to flip the coin 25 times, what's the probability that you'll get 20 heads? Or if you were playing against a certain team and you played against it 5 times, what's the probability that you will win at least 3 of those games? Or if you had a more serious problem, say you're testing burglar alarms, what is the probability that that burglar alarm will fail and 350 times that it's set off, or should have been set off? Again, because of this particular class, nothing's derived here. I'm not going to show you how you get these formulas. I'm just going to give you the formula and the method to solve it. Here's how you specify these kind of problems. First, you have some variable and you know you're going to have wins or loses, and you decide what's going to be your success, and you're going to give that the probability for P. But you're going to do this over and over again. You're going to play this other team 5 times. You're going to throw the coin 25 times. You're going to test the burglar alarm 350 times. So that would be the number of what are called trials. You say n equals 25 or n equals 5, whatever the number of trials are. Then you specify the probabilities for P and Q. Usually, like I say, they're given. If it's a fair coin, then the probability that will be heads or tails is equal. So it has to be 0.5 or 1/2 for the probability of getting heads. The probability of not getting heads is also 0.5. If someone tells you that the probability of winning a game, say, is 0.63, the probability of losing it is 1 minus 0.63, or 0.35. So you need to specify the number of trials. You need to specify the probability of winning, from which you automatically get the probability of losing. And now you have to specify the number of times that you want to win, or that you are trying to figure out the probability for. So say I'm going to flip the coin 25 times. I want to know if I can get 20 heads. What's the probability of having heads come up 20 times? Or say I want to win 3 of the games out of 5. What is the probability of that happening? Then the variable x is set equal to 3, or to 5, or to 20. Well, this should have been 3. Okay, here it will be 20. It's the number of times that you want success. Some authors will use k instead of x. And then, with no derivation, here's the formula. The probability for x happening, that means, for example, 20 wins, is n factorial. That's the whole number of games. Let me write some numbers here. So that would be 25 factorial, button on your calculator, right? Divided by 25 minus 20 factorial times 20 factorial, all these factorials. Then multiply that by the probability of winning, which is, in this case, 0.5. And I'm going to run out of room. Raised to the 20th because the k is 20. And then I have to multiply that by the probability of losing, 0.5, which is raised to the 25 minus 20. Right. In other words, this is pretty easy to fill in. Let me erase this for a minute and point it out again. The n are the total number of trials. How many games you're going to play, how many times you're going to flip the coin. X is the number of times you want to win. P is a probability that you can win. Q is a probability that you will lose. If you have a calculator like that Casio that I recommend, there's another button you can use. I'm going to use the notation from the previous chapter. So this is the number of combinations of n items taken x at a time. Okay, that's a button on the calculator, times p to the x times q to the n minus x. So instead of doing this, which takes some time, you can replace it by using that button on the calculator. Put the n in first, hit the button, then put the x, and you'll get the answer for that. There's another way as well, but this is the calculator way. Here's the other way. Use the table in the back of the book. It's table B, but it occurs in Appendix C, and I mentioned that in the notes. Very confusing to me, as I spent a lot of time in Appendix B looking for table B, but it's in table C. In fact, it tells you clearly that in the book if you are a careful reader, which I am not. At any rate, you want to find the binomial probability distribution table. This isn't the one from the book. I just got this off the internet so I can show it to you. But it's set up like this. You'll have two leading columns. One has the n for the number of trials, the other has the x instead of that r for the number of times you want to win. So this is, the n is the trials, the x is the number of wins that you want, or you want to investigate. You see, if you have two trials, there's only one possibility. There's only three possibilities, I'm sorry. Either you don't win at all, you win once, or you win twice. If you have, for example, play 3 games, you could lose all of them, win 1, win 2, or win 3. See how it's developed? Okay, the homework assignment asks you to do things for 7. So here's 7 trials. You could win 0, 1, 2, 3, 4, 5, 6, up to 7 of them. That's why, you see, for each n, you only get so many x's. Right? I hope that's kind of clear. Now the top row, that's the probability. So if you want to find the probability that you will win 4 games when you're playing 7, and your probability for winning was 0.4, then you, let me get the highlighter. Okay, so 7, because that's the number of games you play, 4, because that's the number of times you want to win, and you move over here along this row. I'll do this whole row here. You're looking along that row, but then you look down this column, 0.94. Okay, so that would be the probability of winning 4 out of 7 games when the probability for winning was 0.4. All right, if you wanted to find the probability that you could win 2 of those games, 2 out of 7 games, you do the same thing. You look for 2 games. If the probability for winning was 0.4, now the probability of winning both of those games is 0.261, 26%. So you just go to the table in the back of the book and trace through it. If you fix the probability for those tables that you have to draw, you have a probability of, say, 0.3. Here's your probability for winning 0, 1, 2, 3, 4, 5, 6, 7. They're all listed right here, and those are the numbers that you would graph. or you could calculate them on your calculator. So here, just to review, and this is what you have to do for the homework. What is N? It's a number of trials, or the number of games. Use this called trials. P is a probability of success. Q is a probability of failure. And that's 1 minus the probability of success. X are the number of times that you want to win, the number of successes you want to investigate. Now you have to graph the binomial probability density for 7 trials, so that's N equals 7 for P of 0.5 and P of 0.3. You can use a calculator or table B in Appendix C, as I mentioned. You need to find the probability distribution or binomial probability for x of 0, 1, 2, 3, 4, 5 up to 7. And then you graph 3 points, and you can use a star for each point or line. You'll get something like this. Of course, you're not going to have this many stars because you only have 7. N is 7. You'll only have 7 stars. Here, N was 40. Okay, so you had 40 trials. P was 0.5. And now the number of success, X. So this is total failure, 0 successes in 40 trials. Here would be everything successful, 40. This would be 20 successes in 40 trials. And the probability is 0.5, so you'd be looking down the column under the P of 0.5. And that's how I found these values. And you will do the same thing, but instead N will be 7, and the probability will have 2 different values, so you'll have 2 curves on here, not just one. You'll have 2 curves. The x-axis will be the same. It will be 0, 1, 2, 3, 4, 5, 6, 7. So you're still going to have 7 here, but this will differ over here, and one curve will peak, and the curves will have different peaks. They'll look different, slightly. The next part of this assignment is to work out, just give the value for the probability, not graph it. And you're given N, I can't remember what the one was in the book, say N of 7, P of 0.3, and X equal to 3. You go to the table, you find the box for 7. You look down here till you find this is the N column, this is the X column, you find the 3. Then you'd move over until you were under P had 0.3 above, and then you would find that value right there. Now there's 2 other cases to solve. One is at most, and the other is at least. If you say I want at most 3 wins, that means you'll settle for 0, 1, 2, or 3 wins. So you have to find the probability for 0 wins, 1 win, 2 wins, 3 wins, and of course those are going to be over here in this column for the probability that's specified. And then you add those all up. So you take the probability for 0 plus the probability for 1 win plus the probability for 2 and the probability for 3, and that's your probability for at most 3 wins. The other case is at least. If it's at least, that means okay, N is 7, probability is 0.3. You want X to be at least 3. Then 3, 4, 5, 6, 7. You'll settle for any of these. That's acceptable if it's at least 3. So there's 2 ways to do it. There's also 2 ways to do this. I'll show you in a minute. You can add, again, the probability for 3 and 4. Oops, I'm sorry. 5, 6, and 7. Okay. You could add all those probabilities up, and then you will find the probability of at least 3. So it's 3 and everything higher, up to the number of trials you have. The other way to do this is to remember that probabilities have to add to 1. So let me clear this off for a minute. Okay, so because it has to add to 1, if it's at least 3, I'm going to write these out. 1, 0, 1, 2, 3, 5. Okay. You could find the probability for, you could take 1 minus the probability of 0 minus the probability of 1 minus the probability of 2. That is the same as adding all these probabilities, you could take this shorter list and subtract it from 1. That would give you the same answer. Because remember, all the probabilities have to add to 1. You can do the same thing for the at most. It just depends on which numbers are smaller. For example, if you had, say, n was 95, and your problem was at least 93 successes. Well, the long way to do it, you would have to add the probability of 0 and 1 all the way up to 93, which is a lot of work. Okay, so that's too much work. We'll just kind of cross that off. The other way is to take 1 minus the probabilities you don't care about. So 1 minus the probability of 95 and minus the probability of 94. That's a lot easier.